Hello viewers. It's a horrible wet miserable day outside and therefore the perfect time to make a YouTube video. A member of our local club was bemoaning the fact a few months ago that it's not possible to, or at least it's very difficult, to modify modern crystals by grinding them to raise their frequency. I'm talking about the ones that are contained in small cans like that. That's an HC49U. Because the electrodes are evaporated metal onto the quartz itself, and so you have to remove the electrode, the contact electrode, initially in order to grind the surface underneath. And crystal grinding is a tricky and bit of a hit and miss process anyway. Well, it occurred to me that maybe there was an alternative way of doing it by increasing the mass of the oscillating crystal. And this has been done in the past by, for example, marking them with pencil or pencil lead or Indian ink or things like that. But there's not a great deal of control in that. So my idea was to copper plate the electrodes on the crystal itself in order to increase the overall mass and see if I could shift the frequency of the crystal in that way. Well, our local top band net is conveniently on 1.79 megahertz, which is not too far away from 2 megahertz, and 2 megahertz crystals are still reasonably easy to obtain, albeit they are very small indeed. So the idea was to see if I could controllably reduce the frequency of a 2 megahertz crystal down to something close to the net frequency, and I've managed to do that. Experiments have suggested that I can reduce the frequency of a 2 megahertz crystal down to about 1.850, after which they refuse to oscillate anymore. Your mileage may vary, as the Americans say, but it's worth a try. As to whether it's possible to strip the copper back off and start again if you go too far, that's for further experimentation. But in the meantime, let me try and show you the technique I've used to modify the frequencies of some of these crystals. Well, here's a general view of the workbench where I'm operating at the moment. And the apparatus I'm using is fairly straightforward and simple. It's just stuff that I've got around the bench generally, and there's nothing particularly out of the ordinary. You're going to need a little bit of glassware. It doesn't have to be glass. You could use any suitable container for an aqueous solution. And we're going to be plating from copper sulfate. And copper sulfate is usually in its hydrated form CuSO4.5H2O, the pentahydrate. Sometimes people ask about whether this is poisonous or not. Depends what you mean by poisonous. Handling it generally will not cause you any significant harm. It is toxic to fish and other aquatic life, so just be careful how you dispose of it. We're not going to be using large quantities of it at all, and so this shouldn't cause any difficulties. The amount that you're going to need is quite small. I've got a 100ml beaker here in which I do all the plating work, and for 100 mils solution all we need is 12.5 grams of the hydrated copper sulfate. If you want to know what 12.5 grams of copper sulfate looks like, that's it. Okay, it doesn't have to be exact. If the concentration is too low, you will have difficulty with oxidation of the contacts as they go, and it'll be a very slow process. If it's too high, the plating rate may be too rapid, but in general 12.5 grams in 100 mils of water is fine. This is what chemists would call a 0.5 half molar solution. So you don't need an awful lot. Copper sulfate can be bought from a variety of online sources, and as I say, it is not horrendously toxic, so just common sense is required in handling it. You're going to need some water as well. Tap water is perfectly adequate for this purpose. You don't have to do anything particularly special. You're going to need your crystals. I'm using, as I say, these HC49U types. There are other types that you can open up and get into. Now, a friend of mine assured me that these crystals had their cans soldered on, and yesterday I managed to destroy one, discovering that in fact the can was welded on as I had suspected. So it is necessary to cut into these and remove the outer can. Re-encapsulating them afterwards, I'll mention that later on. But you're going to need some simple tools to get into these things. They are hermetically sealed, but they're not under vacuum or anything like that, as some people have suggested, and the contents will be either dry nitrogen or possibly just dry air inside there. When you buy your crystals, remember you're messing about with the frequency of them, so you don't need them to be high tolerance crystals in the first place. Okay, don't go buying 10 part per million or 5 part per million crystals or anything like that. 30 is perfectly good, and they're often quite a bit cheaper. So you're going to be adjusting the frequency and tweaking it presumably in your circuit later on anyway. So that's all you need. To get into these, I have a small bench vise and a junior hacksaw with a nice sharp blade on it. No blunt or dull blades or rusty blades, please. That's not going to do you any favours. For the plating process, you're going to need a counter electrode. I use a little piece of clean double-sided printed circuit board of no particular size. It's about 5 centimetres long by about 1 centimetre wide, but it's not exact. I didn't cut it to be exact. I find one of these helping hands things does help a lot in the process. You're going to need some clip leads. You're going to need a way of measuring current reasonably accurately around about the 50 to 100 milliamp mark. You're going to need a power supply, preferably a lab power supply. It doesn't need to be high voltage. You're only going to need about 2.5 to 3 volts. Some power supplies don't go down that low. So do observe that. You might be able to get a 5 volt power supply to work, particularly if you build some kind of current limiter to go with it. Ideally, again, one where you can set into constant current mode. And I've got an old Farnell one that does the job just fine. Apart from that and some other general tools, you're going to need some crocodile clip leads to connect everything together, or otherwise bits of wire. I leave to your ingenuity. And you're going to need some form of test oscillator to test your crystals as you go. The test oscillator I've got is a very simple 1 transistor circuit. It does tend to overdrive the crystal. I don't care. All I want to do is check that it's oscillating and measure the frequency. For that, I have an oscilloscope, which is not an essential item in this process, and I have a cheap but reasonably accurate and reliable digital frequency meter that I bought from a popular internet purchasing site for very little money, considering what it is. Obviously the frequency range has got to cover whatever you might want to experiment with. One other piece of apparatus that you're going to need can be stolen from any teenage daughter, or possibly from your wife, or even your son. A cheap hairdryer. I actually bought one, again, not very expensive. Don't have to be very powerful, but just enough to be able to dry off the crystal to be able to test it, and it's got to be dry when you test it for its frequency. So that just helps to dry it off in between plating operations. Well, the first trick is to get into the original crystal. And this is a technique that I have by no means perfected, but I have had a degree of success with it, and this is where the experimental part may come in for some of you. So a small bench vise, a reasonable amount of pressure, don't crush the thing. And what I'm aiming to do is just to break through the outer casing on the edge here. And it takes a little bit of work, a little bit up from the joint, and I'm just keeping an eye open for when I, whoops, see what I mean? These things always go wrong when you're trying to demonstrate it. That is already through the outer case there, and I want to go just a little bit further to make sure I've got it clear. I don't want to generate too much swarf. Don't have to worry too much about it. These things are quite tough, really, but we need to carry out the process on both sides initially, and then we've got to cut across it. So that's a bit better on this side. Again, I'm just cutting into it here. I'm just about to break through, I think. And yeah, I can see that at the top edge there I've broken through. I may be a little bit close to the base on this side, but that should do it. Now the slightly trickier bit is the edges, because gripping these round sides cut, gripping these round sides is a little bit more difficult and needs a little more care, and I usually find that keeping a finger underneath as a support makes it easier. Not that I usually have this much trouble, but I am trying to demonstrate. So okay, so here we go. Let's just see if I can cut across here. Once you've actually scored a line in the case, it's not too difficult, provided, as I say, you have a decent blade. And just keep checking for when you eventually break through. And it does get a little more difficult to do once you've broken through. There we go, and I've just cleared that there. There's a little fillet of metal there that I don't want, that I'm going to try and remove. You may find a needle file is a better way to do this. It's up to you and your ingenuity. If you don't have a reasonably delicate hand for these things, then maybe this whole thing is not for you. And of course the really careful part is when we come to remove the crystal from what was its home. There are two very fine wires at the bottom of the crystal, and I don't know if you can see this, I'm slightly off in my measurements, and I'm just trying to break through a very last piece of metal, tiny little fillet of metal holding that on there. And there we go. Now I have clunked this one a bit. don't know if you can see, let me remove this. I don't know if you can see, I have actually knocked this off to one side. Now, the mounting wires are usually fairly tough. We'll see in a minute whether this has survived or not. And I can, to some extent, manipulate things back into position if I'm very careful with a pair of tweezers. As I say, the mounting wires are fairly tough. Famous last words. Right, on to the plating process proper. I've set up the power supply to about 2.5 volts, that's all it needs to supply. I have a multimeter set up on the 200 milliamp range. I'm hoping to measure about 50 milliamps current flowing. I might tweak that otherwise. At this stage you are going to need some paper towels to hand, just in case you have to mop anything up. I've already spilt some copper sulfate, but only a tiny drop. Something with which to manipulate the crystal without touching it, and whatever you do, do not get fingerprints on the surfaces of the crystal or its electrodes, particularly at the start. Okay, we want a nice clean surface for plating there. Don't worry if there's a bit of discoloration when the crystal comes out. That doesn't matter. That's quite normal. That there's been a little bit of a corrosion on the surface, and the silver is not the same colour all the way across. You'll need a notebook, okay, to note the time, the current that's flowing, or at least the average current that's flowing, and the frequency at each stage, starting with our initial measurement of 1999.77 kilohertz. Again, we're not going to get perfect accuracy on this process. You may wish to tweak the crystal by pulling it just a tiny bit with a variable capacitor or an inductor or both when it's in circuit, if you need to tune it very precisely, but again, that depends on your particular requirements. And you need some way of timing the whole process, and I'm fortunate enough to have a wristwatch that's quite good at doing that. At this stage, there are only two criteria that are two measurements that are absolutely critical: the current that's flowing and the time for which it flows. That determines the amount of copper that's deposited on the crystal. That's all you need to worry about. Other things, the solution concentration, the spacing, the positioning, will affect the current, and you need to set that up. I set that up initially just to test with a small piece of printed circuit board, and running that just for a short while helps to get out any impurities that might be in the copper sulfate. But you're not too worried about the purity of the copper as long as the quality of the coating is quite good. But timing and current are important. Now, I'm lucky in that I've got a timer on my wristwatch which actually, if I can remember how to set it properly, which actually allows me not only to set 0 but to set a 5-second countdown as well, which helps quite a lot. So we're going to have a go with this now and see how this goes. Now, I've got the crystal connected in a crocodile clip here with both leads connected into the crocodile clip with a good strong, a good solid connection there, nothing flapping about. I want to plate both electrodes of the crystal evenly. I'm going to immerse it in down to the base, agitate it around a bit. If there's a bit of copper gets deposited on the contact wires, it doesn't matter. If anything, it'll strengthen them and make things a bit better. And initially, because I've done previous experiments, I'm going to run this for 1 minute in the plating solution, and then before I do the first measurement, and then we'll see how that goes. So I've got everything set up, I've got the current ready to go, I've got the power supply on. I will now set the timer running, and I've got a 5-second countdown. Okay, and it's straight in, and I've got, okay, the current's dropping off a bit here, so I'm going to, no, it's tweaking, it's going up. Okay, it may vary a bit initially. It's at about 48 milliamps. 15 seconds, I can already see that plating is taking place on the front face. Here, 48, 47.9 is close enough. It will vary. That's not a big deal. 55. 1 minute and out. Straight into clean tap water. Just give it a bit of a shuffle around. Now there, I don't know if you can see it, there is a beautiful salmon pink deposit of copper. And that's what you're after. Doesn't have to be shiny, it won't be shiny. But that salmon pink colour, a nice even coverage. There's a few little spots that are missed, probably due to impurities on the surface. That's not a big deal. Give it a good old rinse in there, and then what I do is I just blot out the section just beneath the crystal and the base, because that's where water tends to collect. And I don't usually touch the faces at all unless there's a lot of water clinging to them. Hairdryer, warm setting. Water's evaporating off nicely. Don't want to overheat it because that will affect the frequency. Nice and dry around the base as well. That's pretty much all you need. Now, again, as usual, handling. I like to use a decent pair of flat bladed tweezers. Take them out and put it safely in a piece of foam. The fact that this is conducting foam is neither here nor there. It's not a static sensitive device, it's just that I happen to have some foam around. Okay, now for the testing process, and we'll see whether this is still oscillating and what its frequency is. Well, I've checked it on the oscilloscope and it's still oscillating. And I'm checking the frequency now, and I'm getting a frequency pretty much what I would have expected from previous experiments. 1991.49 kilohertz. So I'm going to make a note of that in my notebook. You can see we pulled it down about, not quite 10 kilohertz in a minute, which gives you a good deal of control if you think about it. That's about 1 kilohertz every 6 seconds. So you can certainly get to a few hundred hertz accuracy on this without any difficulty whatsoever. Right, back to the bench, and I've done my quick calculation. In 60 seconds at 48 milliamps, we went from 1999.77 kilohertz to 1991.49 kilohertz, at least according to my frequency meter. Whether it's that accurate or not, I don't know. Which comes out to 138 hertz per second. And it is pretty linear, actually, until the crystal stops oscillating altogether. The change in frequency is almost perfectly linear with the mass deposited. And so, if I go for another minute, I should get to somewhere in the region of 1982 kilohertz, which is pretty close. I could try and go straight in and time it for my target, which is 1979, but I think what I'll do is I'll play safe and do it for one more minute and see how it comes out after another minute. And we're off. Okay, well the current has gone up this time to about 52 milliamps. I've noted the previous one down, so it's a little bit higher than it was. Oh, it's dropped back down again now. There will always be some variation. It's inevitable. You don't have to worry too much about washing the crystal. As soon as it's out of the solution, the current stops flowing, the plating stops, but you don't want the copper sulfate solution drying on the crystal. So I'll just prepare it as I did before and see what the result is. It's still oscillating. Confounded me slightly. 1983.14 kilohertz. So not quite as far as I thought. I'm out by a kilohertz there. So then we just need a quick. Further step to see how if we can get just a bit closer to my target of 1979. Well, how's about that? No faking. 1979.21 kilohertz. Close enough for AM, or I could tweak that further very easily. I could pull the crystal slightly if necessary. Now I did my calculations based on the 2 minutes worth of plating, and it came out to 138.6 hertz per second, which meant that I needed almost exactly 30 seconds to hit the target frequency. So trusting in science, I gave it another 30 seconds in the plating bath at 50 milliamperes, and I've ended up within 210 hertz of my target value. If I was feeling really brave, I might even try and just take off that last 210 hertz, but 1 second immersion, I don't think I'm feeling that brave. I think that'll do enough for the purposes of this demonstration. The final part of our story is what to do with our little naked crystal that we have here, which can't go back into its original home. Now, it may be perfectly okay as it is for your purposes. It's quite resilient, provided it doesn't get mechanically punished wherever it's located. So you could solder this into a circuit board and completely enclose the circuit board for an oscillator or something like that without any major problems. If you were careful whenever you opened up the container, that would probably be all right. But what I prefer to do is to protect them a bit and put them in a suitable alternative container. Now, the smallest suitable container I've been able to find easily is this size. It's a bit oversized, isn't it? But then who cares, really? The wires on the base of this crystal are 0.2 inches apart, so I've drilled 2 little holes in the bottom of this container. These things open up from the top, whether I can do it one-handedly. Oh yeah, I can just. And so that can sit inside. And the only question remains is how to secure it in place. Now you can use super glue. What I've discovered is this rather wonderful material from the States called Bondic. Bondic, this is the stuff that UV curable polymers that your dentist will put in your teeth if you have polymer composite fillings rather than old-fashioned amalgam ones, except somebody at last has actually made it in the form of a clear glue. Comes in a little pen. It's fiendishly expensive. Please Bondic, if you're watching this, get yourself a UK dealer, because I really got stung for VAT and carriage charges on this stuff. It comes in a little pen with a UV LED to cure the polymer when it's in place. So what I do, it's also a form of a little pen here. So what I do is I take the crystal thus, and I'm going to put a little tiny drop just between the wires on the bottom of this. It's a kind of a gel, so it's not too difficult to control, but it is a little bit tricky just locating it in place. I hope you can see this in the container. I've just got to find two holes in clear plastic. Aha, got it. Okay, I'm going to pull it through, right through to the bottom there, so that the base is actually in contact. Now I'm making sure it's in good contact. I'm going to expose it. Only needs a few seconds of UV, and it'll do it through the clear plastic. And that's what happens if you get it off centre. Take two. Well, take two went much better than take one did, but in doing so, I had to manipulate the package into some rather awkward positions, which were not ideal for videoing. So I'm afraid you'll have to take my word for it. The stage at the moment is that I've got the crystal mounted to the floor of the box, but it doesn't have a great deal of mechanical resilience. If there's too much pressure put on the crystal wires, it will push it out of position. It will break the bond and push it out of position. So there's one further step that I go through to improve that situation, and that is to use a little bit more Bondic and to put a bead of the material around each of the wires. I say you don't have to use Bondic for this, but the great advantage of this stuff is it stays a gel. It doesn't do anything until exposed to the ultraviolet light, and so there's none of these problems of super glue that either won't cure or sets too quickly when you weren't expecting it and gums everything up, and that's quite an advantage. It just takes a few seconds exposure to do this, and I'll just test that these are now completely solid. And then we have our package, which our package crystal, which I can label up with its frequency and using a circuit. This one I'll probably use in a little AM transmitter that I'm thinking of building, but we'll see how it goes. And so that's completed the job there, and that's ready to go. All we need to do is just to check that the frequency is still as it was. It may have changed a bit because it's cooled down now. It was probably a little bit warmer after I dried it last time, and that may have some effect. We'll see. There we go, the final proof. Slightly different frequency measured there, but please trust me, it is the same one, and that's our encapsulated crystal. Well, here's our crystal now with some of its friends, neatly packaged and labelled up. I hope you found this video of interest, and maybe encourage you to to try to modify some of the frequencies of your own crystals in a similar way. The technique seems to work quite well. Since I've started making this video, the sun has come out. There's some blue sky, and it's definitely time for a cup of tea, which is all rather good news. So with that, I send greetings from the Echelford Amateur Radio Society to all our listeners and viewers, and wish you success in your radio projects. For now, 7-3.